Let's work on those four problems. The first one is we need to obtain the 10th term of the AP, which is given by 1, 4, 7, 10. So let's begin with the first problem. So here we have our first term. We'll represent with A1, so this is 1. And let's represent the second term with A2, so that's 4. Now, to find out the common difference, all we have to do is subtract the first term from the second term. So here we have 4 minus 1. This will be equals to 3. That means the common difference is 3. Now we know that the nth term of the AP sequence is given by the first term plus n minus 1 times the common difference t. So to find out the 10th term, we will have n value equals to 10. So that means A10 will be equals to the first term, which is 1, added to n minus 1. So in place of n, we have 10. So we have 10 minus 1 times the common difference, that's 3, which will be equals to 28. Let's go to number 2. So in number 2, we have our first term given by square root of 2, and the second term is given by 3 times square root of 2. So that means the common difference would be 3 times square root of 2 minus square root of 2, which gives us the value 2 times square root of 2. Now the nth term of the sequence would be the first term, which is square root of 2, plus n minus 1 times the common difference, that's 2 times square root of 2. Where we need to find out the 18th term. So that means for n value equals to 18, we have A18 equals to square root of 2 plus 18 minus 1 times 2 square root of 2, which will be equals to square root of 2 plus 18 minus 1 is 17. 17 times 2 is 34. So we have 34 square root of 2, which is added to square root of 2 to give us 35 square root of 2. So this is going to be the 18th term of the given arithmetic progression. Number 3. So here we have our first term given by 13. The second term is 8. Now the common difference will be A2 minus A1, which is 8 minus 13, and this gives us a value negative 5. Now we have to find out the nth term. So our nth term would be the first term, which is 13 plus n minus 1 times the common difference, that's negative 5, which gives us 13 minus negative 5n plus 5, which will be equals to 18 minus 5n. So this is going to be the 8th term of the given arithmetic progression. Coming to number 4. So here we have a sequence an, which is an AP. We need to show that the m plus nth term added to the m minus nth term is equals to 2 times the mth term. So let's do that as well. Now, here we have the sequence given by an. So if we expand this would be the first term would be a1, the second would be a2, the third would be a3, and this goes on. Now let's consider the first term and the common difference. So we'll call the common difference, which is a2 minus a1, or any term minus the preceding term. This will be equals to the d. Fine. Now let's start with the m plus nth term. So this is equals to a m plus n, which will be equals to the first term a1 plus m plus n minus 1 times the common difference d. I'm going to label this as number 1. Then the m minus nth term, this will be equals to a m minus n, which will be equals to a1 plus m minus n minus 1 times the common difference d. We're going to label this as number 2. What we'll do, we'll add 1 and 2 together. So this will give us a m plus n. This is the m plus nth term plus the m minus nth term, which is going to give us 2 times a1 plus. So here in the second term we have d as the common factor. So this will get multiplied to m plus n minus 1 plus m minus n minus 1. So here positive n, negative n goes away. So this leaves us with 2 times a1 plus, so we have 2m minus 2 within the parentheses. So if we factor out 2, so we have 2d times m minus 1. Right. So this means we have 2 all multiplied to a1 plus m minus 1 times d. And this by definition is going to be the mth term. So that means we have successfully shown that the m plus nth term added to the m minus nth term is equals to 2 times the mth